We are going to continue with the AC current, and we are going to start with the topic about the bonding. What is the meaning of the bonding and why we need a bonding? But before we make a drawing about the bonding, I want to explain one thing is about the static electricity. What do you think is static electricity?
Electricity that's not moving.
It's not moving, it's static, thank you. That's perfect. And how is produced static electricity, guys?
Electrons that escape from.
Exactly, electrons that escape from the rotor of the motor when the motor is spinning, no? Those electrons jump it. And where will be located those electrons?
In case, you know.
In the case of the equipment, the case of the refrigerator, the case of the any appliance, and that's why in the appliance you have that ground draining cable, no, the drain cable to drain those static electricity. In your home, where are going those electrons that you drain?
In the ground.
To the ground, the copper rod that you have in the backyard of your home. This is the ground, and all the green cables, all the grounding cables, go over there and drain over there. Let me explain something about that. This is the ground in your home, the copper rod that is on the ground directly. What is the ground in your boat? The physical ground.
The sink and the sand.
Yeah, the sacrificial anode that you have in the transom of your boat. All the currents drain over there in that anode, and that anode is in contact with the water, dissipate the current in the water, and the water is in contact with the sand, with the ground. This is the ground. The copper rod in your home is the sacrificial anode in your boat. That's correct, guys? Yeah, it's clear? Okay, what type of current produce more static electricity?
DC.
AC or DC?
DC.
AC.
Okay.
AC. It's basically because the alternation. Alternation, correct. The other one is straight. Yes, for that reason you see that in small boats only with DC current, in those boats you don't have a bonding dedicated. No, you have basically the sacrificial anode that you have in the outboard motor, and that's it. No, because you don't have a number one, because you don't have a lot of appliance, and because you don't have AC current in the boat. When you introduce AC current in the boat, your problems start because you need a start to think how I am going to drain all of those static electricities accumulated in any metals in the boat. Is clear that situation? For that reason, the bonding is necessary, it's mandatory. Especially in medium boats and big boats, when you have AC panel and DC panel, you need drain currents. And not only those static electricity currents. In some cases, what happens if one hot line is touching the metal of the frame of any equipment, the block of the engine? What happens with that hot line? Make a short and the current is drained. In some cases, that bonding conductor, that grounding element, drain big currents. It's for a short period of time, but it's designed to drain. For that reason, is the gauge of that wire. Is because what happened in the moment of the storm during the lightning is a lot of voltage, no? It's millions of voltage and high currents. Those currents are drained through the bonding, into the sink, into the water, and finito, bye-bye. For that reason, a good bonding system is necessary, it's mandatory. In boats, in sailboats, more, because you have that long piece of metal, and it's easy the connection in between the cloud, and if you don't have a good bonding, good lighting protection, you can destroy the boat. What happens if you have bad bonding or no bonding? Okay. Only we are going to imagine that I have a dishwasher with no bonding in my boat. And all the static electricity accumulated storage in the case of the dishwashers is over there. The case of the dishwasher is in steel. It's not a stainless steel, it's good steel. And the rivets are in copper. And the frame is in aluminum. You have the similar metals together with electricity accumulated over there. The more noble metal destroys the less noble. And in a couple of weeks, wow, the dishwasher is completely eroded, especially around the rivets, around the, where the different metals are together, the humidity in the environment and the electricity accelerate the corrosion process. That's the problem if you don't have bonding. If you don't have bonding, the process of corrosion starts and moves faster, and your boat is destroyed. Yeah? For example, it's common that you have a boat with two engines, starboard engine and port engine. The port engine is properly bonded to the bonding conductor, and the starboard engine no. The bonding cable is broken. And you receive the phone call from the customer, I don't know what happened in my boat. The port side of the boat is corroded and the starboard side is clean. It's because the connections in the port side are not good. That's the reason. Yeah? Yeah, the bonding is necessary. It's mandatory. Okay, this is the number one. Understand that the static electricity should be drained. If not, that electricity accumulated accelerate the corrosion in between the similar metals. What is the name of that corrosion when one metal with more energy, more noble, attack the less noble metal? Galvanic corrosion. And what is the name of the corrosion when you have those two dissimilar metals together in a marine environment, but additionally a current is passing over there?
Electrolysis?
Electrolytic corrosion or electrolysis. It's the same. No? Electrolysis is galvanic corrosion plus current. Finito. That's okay? Okay, we are going to check the diagram that I have here in the board. It's basically a typical boat with a AC panel, with DC panel, with one inboard engine. That's the engine, the transmission, the propeller. This is the switch selector, you remember? A couple of batteries, one cable for the DC panel, house battery, and other cable for cranking battery. You did that project. This is the DC portion of the boat. In the DC panel, you have a breaker, the main breaker. You have a small breaker and the negative bus bar. You remember? Mm-hmm. You remember that, guys? Yes. You did that installation. And now in the AC side, I have three sources of power. One source of power is the pedestal. Other source of power is the generator, and the other one is the inverter. Yeah? The inverter converts DC current into AC. Convert DC into AC. That's the function of the inverter. Ready? Okay. I have three sources of power. Okay, the AC power from the pedestal enter in the outlet of the boat, and enter in the breakers. One breaker for short power. This is generator, and this is inverter. That's okay? Look, the current from the generator, hotline, and neutral enter in this breaker, generator. The current, hotline, and neutral enter in this one, short power. And the current, hotline, and neutral enter in this breaker, inverter. That's okay? Later, I am going to explain how we connect that one to enter in the panel. It's simple. I am going to connect all the hot lines together and all the neutrals together. From the common connection of hot lines, I enter in one transformer, and from the neutral, after the transformer, I have hot line and neutral. This is the hot line and neutral enter in the main breaker. Entering in the main breaker of the AC panel. The hot line feed the hot line bus bar, and the neutral feed the neutral bus bar. And now I am going to connect appliance. Okay. Clear, guys? We are going to try to understand what is the meaning of this transformer. The name of that transformer is isolator transformer. And also the ground. The ground of the pedestal, the ground of the marina, enter in the boat, but that ground no pass for the breakers. That ground goes directly into the ground bus bar. And the ground bus bar is connected with the bonding conductor. And the bonding conductor is connected externally with the sacrificial anode. Until this point is clear, guys?
Yes, sir.
Sure? The ground no pass for the breakers. In the breakers, you interrupt hot and neutrals. No ground. The ground goes directly into the ground bus bar. Never interrupt the ground on the breaker. The breakers only interrupt hot lines and neutrals. Ready? Okay. This is the ground, enter here, and the ground is connected with the bonding conductor, and the bonding conductor finishes into the sink. One thing that I need that you keep clear from today to the rest of the line. All right, look, in one side of the inverter, enter DC. And in the other side, you have hot, neutral, and ground. You see? Hot, neutral, and ground, and this is the hot, neutral, and ground that you introduce in the AC panel. This is the inverter. The input is a group of batteries, DC. And the output is AC. Oh, how many batteries I need? Okay, I am going to explain later in the chapter 15. Oh, this inverter is for 4,000 watts, 4 kilowatts. I want 4 kilowatts in the output. How many batteries I need in the input? I'm going to explain the procedure to calculate that. All right? Because I want 4 kilowatts. With that amount of power, I am going to feed the AC panel. How? Like this. I have one breaker for inverter, other for generator, and other for short power. Short power, this one for generator, and the other for inverter. This is the cable that enters here in one of the breakers. That's clear, my friends? And in the bottom, I connect the outputs ready to feed the panel. Good? Okay. Pay attention to this explanation. Always, 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 only at the source of the power. What is the source of the power?
Where is it coming from?
This is one source of power. Other source of power is the generator. Other source of power is the pedestal. The pedestal is coming from the transformer that you have in front of your home. That transformer is source of power. In those sources of power, only in that point, the ground and the neutral are together. After that, one cable goes white color, neutral, to feed the neutral bus bar in the panel, and other cable from the housing of the equipment is going green color, separated. Listen to me. Only here, neutral and ground are together. After that, both cables travel different and never will be connected again together. Only at the source of the power. Anybody follow me?
Yes, sir.
If you check the pedestal, any type of pedestal, the pedestal, they have neutral bus bar, ground bus bar, and other ground hotlines. The neutral bus bar and the ground bus bar in this point are connected together. After that, neutral is separated, ground is separated. Only at the source of the power are connected together. ABYC question. Where should be connected the neutral and ground together? Only at the source of the power. Can I connect internally? No. Will be catastrophic if you connect neutral and ground together inside. Oh, Mr. Lopez, but no makes sense because if at the beginning, yes, it's only at the beginning. After that, no. Everybody, clear, my friends? Clear that concept? In the boat, no connect together. This is the difference in between an residential and industrial electrician and a marine electrician. The marine electrician have clear that a neutral and ground should be separated. Only at the source of the power, neutral and ground are together. After that, they travel in different cables, white and green. Good?